Today, we are unpacking or understanding a model per customer approach. This is a topic Nicola recently wrote a blog about, and today she's going to be leading today's discussion and presenting and sharing. I think she's also joined by Eric, and I think he will cover some more of the technical detail. With that said, I'm going to hand over to Nicola.
Thanks for the intro, Maddie. So we're going to keep it quite conversational today, just because it is quite a technical subject and I didn't want to overwhelm people with too many details. And Eric has a gift for explaining things. So yeah, we're going to be kind of just talking about the model per customer approach and what it is and why a lot of enterprises struggle to implement it and what our solutions for that are. So Eric, I want to start off by asking you kind of what the common strategy is that enterprises are currently using when it comes to machine learning and kind of tackling the personalization at scale problem.
So, yeah, I think specifically in terms of personalization, there's probably two broad categories of approaches. So the first is a segmentation-based approach. So they will have used some sort of technique to derive customer segments that they will put people into, and those could be based on a number of metrics, and it could be from something as simple as what is the type of product you have with the company. So like in a bank, what is your account level or something like that, or it could be a more complicated combination of factors and use some machine learning algorithms to derive the segmentation. And then based on that segmentation, the engagement will be different within each of those segments. So the product and marketing teams will get given an understanding of what each segment is meant to mean, and then they will construct their journeys and messages and offerings and all of that based on that for each segment. The second approach is to build some sort of model to predict which engagement is going to be most effective for a specific person given the data points that you have about them. So you would have a set of, again, messages, offerings, journeys, whatever it might be, and you'd build a feature store about each customer with things which could go from things like the product that they have to sort of behavioral things or things like when did they last transact with you, all that sort of stuff. You would use that to predict which will be the most likely thing to get them to engage with you. So which would be the best message or offer or whatever it might be. So that model will then be run across the whole base and the results will be used to drive your engagements. You do also get sort of a hybrid approach where you will have the segments and then you will build, so say you have 4 different segments based on whatever criteria, and then you build one model for each segment because you have some belief that the segments behave differently enough that that's a useful thing to do. You use the model outputs to drive that customer engagement that you're trying to have. Some things just get sent out generically, and sometimes that's the right thing to do because it's, maybe it's governed by regulation that you have to do it in a certain way, or it's seen as low impact, or there's just not the capability. So that does also happen. I think in terms of people who are doing some personalization, that's kind of the 3 broad categories of things that happen.
Okay, and then just for the purposes of our discussion today, you mentioned the approach where a model is trained on a population, so a certain segment, and then every individual within that segment is compared to that model. So in a sense, what's happening is that people are being compared to one another within a segment to deduce what the best approach would be with that individual. Is that correct?
Yeah, effectively. So you're kind of saying, what do people who are close to you in the data set, what have they done historically? And we assume because they are close to you in the data set, and by close to you, I mean, so maybe they have a few similar features, like maybe in the same age bracket and the same level of of transaction frequency, and those are two important factors to the model. It will look at people like that and say, these people behave similarly, and these are the sort of ways that it's effective to engage with them.
Is that almost like a form of collaborative filtering, or is it like based on the same concept?
I mean, collaborative filtering is the same concept. It's just collaborative filtering is like a specific algorithm that
Yes.
you can use to recommend. This applies more broadly. So collaborative filtering does do that. It will look at people who are similar than you and in space.
Yeah.
But that's generally what happens in other approaches as well.
So what's happening is that individuals are being compared to one another, but we know that that is not necessarily the best way of conducting personalization, because humans are very different, even if they look the same when they're in a specific group. So what is the best remedy for that?
Yeah, so an approach to work with that is using a model per customer approach. So the idea there is, and it's basically taking the model per segment approach to its kind of logical conclusion. So you're saying, okay, we know that people in different segments have different behaviors when we model them, so we need a different model for each segment. But you can always make your segments more granular. And the end point of that is your segment is one person. And you build a model for each person. And that allows you to give much more personalized, I think truly personalized results, which are based on an individual's past behavior rather than the behavior of people who appear like them in your data set. And one of the reasons that's useful is because a way of thinking about it is, it kind of, your data set is never complete, right? You as a business can never have enough data to completely capture the behavior of an individual, because they exist outside of your world, and when they're engaging with you, there are other things going on. And that's why, even though you say like these people look similar on these data points, one of the ways of thinking about why they will then behave differently. But if you look at someone as an individual and just look at their interaction data for the thing that you're going to predict, you get around that issue, because you can almost think about it as you're capturing all that unseen data about them and using that for your engagement. So it can give you basically much more personalized results, the more generic, broad-based approaches.
Yes. And I mean, that sounds ideal. That sounds like the approach that most businesses should be using. But what are the challenges with implementing this approach? Why are most people not using it?
So there's two sets of challenges, right? There's two types of challenges. The first is it needs to be a situation where you're engaging with an individual regularly enough to have the data you need to build that model. So something like a banking app where we know that people log in from daily to weekly, you have a lot of interaction data, and you can use that to model how to engage with people at an individual level. But something like, say, your life insurance, where maybe you interact with them once a year just to check in on your policy or update it, you probably don't want to follow this approach. So the first is just it depends on a constraint that depends on the specific situation that you're in, which is, do you have enough data on a person to actually build a useful model of their behavior? And you don't need a huge number of data points, but you do need some sort of fairly regular and consistent engagement. But there are a lot of spaces, especially in the types of areas that we're interested in, where that happens. So a lot of your banking, telco, some of your insurance, gaming, all of those places have that sort of characteristic. The second thing is that it can just be technically challenging to do. So for a lot of companies, it's difficult just to deploy a single model to drive some sort of engagement, and doing like a model per segment is already quite a stretch. So doing hundreds of thousands, maybe millions of models is a technically challenging thing to implement and manage, especially following the kind of architectural paradigms that most corporates will have used for their machine learning deployments. They will have designed it for doing one, maybe two or three sort of models, and then to use that same approach for hundreds of thousands to millions of models generally doesn't work. So yeah, there's technical constraints and then data constraints.
Okay, so you said that the model per customer approach is kind of more suitable for environments where there's a lot of interaction quite frequently. So are these models then kind of more dynamic in nature, in the sense that they are like updating their learnings more regularly, more than a static model? Or do you also use static models with this approach?
You can use both. The dynamic models work particularly well because, as you say, it's generally in an environment where there is frequent engagement, which is where the dynamic models would be particularly useful, and you want to capture the dynamics of that person's situation changing. So generally you would, it's not that you can't do it with the static models, but generally you would use the dynamic models in this situation. They work well together.
Okay, great. And then I think, yeah, that leads well into my next question, which was going to be about cold starts, and kind of like when you don't have any data about an individual, how do you know how to approach them?
Yes. So I think in a way it's no different from the general approach that you would follow in a cold start scenario, maybe just with an additional step. So you can, if you have no data about someone at all, like you know nothing about them, then you would follow the approach that you would follow if you have a model or a segment-based approach, because those cases also don't apply in that situation. And that could be that you have a kind of generic model trained, or you're just using a popularity-based approach, or there's a range of different ways of doing that. So when you know absolutely nothing about someone, you need an approach for that regardless, and there's a number of different things you can do there, and you would follow that approach. As you get a bit more data about someone, you can, as a step into the model per customer approach, use a general model or a segment-based approach. So maybe as they're onboarding, you can get an indication of what their money personality might be. And you can use that to give them a personalized but not model per customer engagement. And then as they are participating in that engagement and further ones, you build up enough data to move into the model per customer approach. So effectively you use the existing approaches as like a stepping stone in your cold start thing. And it's not even just for cold start. Some people just won't engage with you regularly enough. So even though we know, again, say to go to banking, that most people log in kind of daily to weekly, there will be people who log in once a month, and potentially for them you want to use a more broad-based approach. So yeah, that's how you should deal with it. Basically follow your normal approach for zero data. As you build up some data, go to a population level model or segmentation, and then once they're engaging regularly with you, you can go to the model per customer approach.
Yeah, I think that explains that quite well. I wanted to stop and see if anyone else has some questions that have popped up. You're welcome to pop in the Q&A or put your hand up. Just checking Q&A. Okay, I'm going to assume no questions right now. Okay, Yeah, so then I wanted to talk a little bit more about the importance of real time for this approach, because obviously it is already quite technically demanding on a system to run so many models, but then at the same time, you need to have that low latency quality, because if you're going to bother with all of this to make something hyper relevant, you have to make sure that an interaction is delivered at the right time. So yeah, if you could maybe just talk a bit about how that all works together.
So I think it's basically in the same way that I was talking about dynamic models pairing particularly well with this. The same can be said for being able to have real-time capabilities. I think it's useful to break real-time down into its kind of four components when thinking about it. So there's real-time data, real-time serving, and real-time learning and updating. So real-time data, you can imagine that as you are engaging with someone, as we've spoken about, having the most up-to-date information about them is very useful because you want to engage with people in the context that they're in, and people's environment impacts them a lot. And that, I think, particularly applies when you're just looking at one individual's data, like having access to their latest interaction when you are predicting how to engage with them next is very important, because that will influence what they're going to do next. So just looking at what did they do yesterday, if they've been engaging with you, if they're busy doing things with you and you're only looking at what happened yesterday, you're kind of obviously missing a very key piece of information. And the same thing applies with real-time serving. To use that real-time data, you need to be able to produce your scores and results in real time using that data. If all you can do is say, like, okay, overnight we're going to kind of generate predictions for everyone based on their models of what they did yesterday, and someone comes in and does something that doesn't follow the pattern of what they have been doing, your model that you produced last night becomes a lot less impactful and relevant. So once you have your real-time data about someone and your individual level model, you want to be able to score that model in that moment so that you can actually use that real-time data, the real-time learning. So you want to be able to update your model belief about how to engage with someone, again, based on the interactions that they are having with you. So if you are scoring someone based on, even if you have today's data and you can score based on today, again, if they do something that breaks that pattern, ideally you want to actually incorporate that into your model, not just your serving. You want to incorporate it into your training as well. So that's why having all of those real-time components kind of works quite well with the model per customer approach. And some of them, in particular, kind of real-time serving, I think is very important, which needs real-time data. So they do fit together and work together quite closely. And I think if you're doing model per customer, you should be doing real-time as well. If you're going through the effort of using that approach and you can kind of get it into your environment, then it's worth being able to do real-time as well.
So then that kind of draws my attention back to the technical architecture that you need, because all of this is very highly demanding. So what role does something like a horizontally scalable architecture play with this?
So it's not so much, I mean, I think the horizontally scalable part is important regardless of the approach that you're following. So whenever you're doing real-time serving and learning and all those things, you want to have something that's horizontally scalable so that you can handle, especially if you're in an environment that has a lot of volume and fluctuations in those volumes. I think the key here is just building something from the ground up that is set up to handle a model per customer approach. Like I said, a lot of traditional machine learning architectures will be designed for a few models at most being run, and you can't just multiply that by 100,000. It's about knowing that this is something that you want to do and building it into the approach that you're using from the get-go. Especially with our dynamic models, we knew that that was something we wanted to do from the very beginning. So it's built into the way the whole thing works, that a model per customer, you almost have to have that as your base. It's like if that's your starting point, then you can also do one model, because it's just then doing like a subset of it. But to have one model as your starting point and generalize that to 100,000 models is much more difficult.
Okay, that makes a lot of sense. I think I've explored this topic to death. If anyone else has questions, please feel free. I'm popping a link to a blog that I wrote about the subject and another one as well for your interest.
Nicola, I've got a question.
Yes.
So Eric, I think that the thing that people sometimes ask us about that's not always clear is the role that your prior history in relation to an algorithm plays when you try to do personalized recommenders.
Yeah, so I think it basically depends on how things get set up. So, if you have historical data about a specific interaction that someone is potentially engaging with, then you can decide to use that or not. And I think you need to look at whether it makes sense behaviorally for that historical behavior to be indicative of what people are going to do moving forward. And potentially you do that on an individual basis. Some people might exhibit pattern-based kind of predictable behavior, and you'd want to use that information and their historical behavior to engage with them. Some people might be quite hard to predict, and maybe it's more effective to engage with them based on behavioral construct like novelty in terms of generating their interactions. So I think the role that prior data has is if essentially you decide what role it has, but to do it effectively, you need to think about, is that prior data the most useful thing you can use for that person, and what alternatives are there? So like, for example, potentially even if the prior data is very useful, maybe like a novelty-based approach is more useful or more impactful, because that person's stuck in a bit of a rut and you actually want to show them some of the other things that you have available. So yeah, there's not one answer. I think it's something that you need to think about when you're building out what the journey someone's going to go through looks like.
But I think isn't the point you're making that often what happens is that you want the new approach to generate data for you that will then give you an entirely new enriched world that you can work from, rather than thinking that you're just going to, or that you have already collected the correct data too. So if you want to use a probabilistic model, something that is more kind of, priors based on the distribution-based models like Thompson sampling and so on, you would need different, sets of data, and you would generate a very rich set that you can then, from the moment you start looking forward, will have a different view. I mean, that's probably a good point as well too.
And I think that's part of the real-time data topic is like, you want to have your real-time data, you need to be recording and logging all of the interactions that you have with people and why that interaction was set up to run as it did. And that, as Jay says, builds up a very rich data set, and that can be used going forward with different approaches or to enhance what you're currently doing. But yeah, it is a very useful facet of the whole thing, is that you build up this rich behavioral data set of someone interacting with you and the engagements that you're generating.
And then maybe also just to talk about the offline, online version, our batch real-time system.
Yes.
Because I think that's a very real enterprise challenge today, because even this week chatting to people, and last week some clients had a lot of client interactions, and many companies cannot ever see, or not immediately see, themselves implementing real-time integrated platforms into their channels. So they need some way to collect the prior and still let the model converge, even if it is a bit delayed.
So there is a kind of an approach where you can design the algorithms in order to not fail if the feedback that you're getting is slightly delayed. I think that's the key thing. And then you can, instead of running the process where after every interaction you learn, you run it in kind of batches where as frequently as possible, you will generate a set of recommendations, feed them into the environment, collect responses, feed that back into your recommendation engine, generate responses, and that sort of mini batch process. And that could be done on using a model per customer basis. I think the longer the time period of your batches get, the more you'd want to think about maybe just doing it at a population level. But yeah, there is a kind of a stepping stone between like complete batch and having many batches with sort of incremental learning at whatever sort of interval you can set it up to do. So maybe you can do it in an hour, maybe you can only do it daily. Depends on what you can fit into your architecture.
We have a question from Dash. Dash is new here, and he's asking whether a model per customer approach is an AI thing that automatically advertises certain products to customers based on the sites they have visited, etc.
So it's a bit broader than that. So it is an AI thing, and it's a specific way of recommending things to people. So it might be that you want to recommend a product to them, as you say, but it could also be that you want to influence the way that you talk to them about that product, whether it's the journey that they're going through or the messaging or a range of different things. And it would generally not so much be based on the sites that they visit, but their interactions with you. So rather than their browsing history, would be like, what is their journey in your app and across different channels of engagement with you, both historically and in this current kind of journey. And then you can use that to predict what engagement you should have with them. And the model per customer approach that we've been talking about is a specific way of doing that. So like we were saying at the beginning, you can have either broad segments that you use to do that, or you can have a model that you've built for across the population that does it, and those will all achieve the same outcome as doing a model per customer approach to recommend those different things. But the model per customer approach gives you a more personalized way of generating recommendations for people that can incorporate some of the hidden data that captures what their behavior is going to look like.
Something came to mind now, like how different is this approach really compared to what people are doing? Like your work in discovery, for example, and the kind of personalization tactics that they were using and the data science tactics that they were using. Like how useful do you think this would have been for you back then?
I think it's very useful and very different. I think, like I was saying, it's kind of a logical extension of, we have 3 products and we've got a model for each product. Like, okay, we've got 100,000 customers. Let's have a model for each customer. Like, so on that level, it's not that different. It's just kind of an extension of that logic. But practically, it is pretty different. So you kind of have to build with that in mind. You can't just take an approach that was designed for 1 to 3 to 5 sort of models and suddenly do it for 100,000 models. Depends on the level that you're looking at. Conceptually, it's not that, it's just an extension, but practically it is pretty different.
Okay. I see we are at 20 to 5, so we still have time. If anyone has some questions, please do ask away. There we go, Jay. Go for it.
The thing we've been discussing a bit is how to test these approaches and to decide which one is best using experimentation. Isn't it kind of a core part of the multi-model approach?
Eric, you're muted.
Sorry, muted. There is a question in the Q&A as well that I think came in before Jay's question.
So Sumit, I was wondering, how do you scale such a highly individualized model while maintaining low latency?
Yeah, so there's a few things there. One thing that's actually very helpful is generally the models and data sets are a lot smaller when you're on a per customer level. So that helps because it just speeds up all of the individual steps. A big part of it is having it be horizontally scalable and having a lot of focus on kind of threading and having things run in parallel. But yeah, generally it's just been a bit of a kind of low latency is a bit of an obsession of ours. So we have been tweaking and adjusting and re-architecting things for years to be able to do it. So there's not, like I said, I think the one generic helpful thing is that everything is smaller when you're doing it at a customer level. But beyond that, there's not like one silver bullet that suddenly it works. It's just like 100 different things that you have to tweak and obsess over and get right in order to do it. I don't know, Jay, if you have anything to add to that, but yeah.
I think that the thing that happens is that if you look at historical machine learning approaches, is that you're trying to train across the entire population. So if you take our thinking around an individual, a collective, and a society, is that if I want to form an opinion about the broader population, then I probably would need to train a model, a static model across everything to make sense of what's going on. Might even train an autoencoder of some sort to give me some insight into the general trends and whatever is going to happen, and that'll inform a better cold start. By the time I get to a collective and it's within, let's say, a certain segment or a certain group, or what we call contextual variables that are set for smaller groups, your model now, your priors become far more contextually relevant. And if you look at a person, an individual person, and you look at how they act in the moment, and you had to think about how many times you've logged onto, let's say, an app, or how many times you search whatever it is, and you sit with a few thousand priors, you can get a typical model to converge in about 15 milliseconds, 20 milliseconds in our stack. So I think that maybe that's kind of the big thing, is that you never just use one. You would always use a multitude of approaches depending on how much evidence you've collected about a person's actions. Because if you collected a low number of evidence points, then you need to decide if you want to get the model, you might rather want to go for the person that looks like somebody else in the collective, and then do an explore to test what is going on, and then go back until you've collected enough evidence about the person's behavior. And that'll then inform. So you can definitely, and that's why we so incredibly focus on high performing scoring, because you want to be able to have those options so that you can decide how many priors you want to include in a. So you should be able to take 2,000-3,000 data points for a particular person and generate, like we know that in our probabilistic model benchmark, it runs for about 16 to 17 milliseconds on a horizontally scalable single instance. So that means you can run that consistently across millions of people. So you can generate huge number of models that are in memory for the moment. And then it generates the history for that. So the only thing is that if you turn on the logging system, that generates an enormous amount of data for you that you can then decide how much of that you want to retain or not. Yeah. So maybe that was just worth noting. Yeah.
Thanks, Jay. I think what's useful about the logging system is that those models are kind of in the moment, but then that all gets logged. So you can see what that model looked like at the point in time when your particular interaction that you're interested in generated, if you store that. It is configurable. So you can store all the data that was used and the parameters and everything, or you can decide not to. It depends on how much that historical explainability and visibility and building up that data set. I think generally it's pretty valuable and storage is cheap, but like Jay said, it can get pretty big depending on how many engagements you have.
Eric, I also have a question for you. I'm not sure if you covered this in the beginning. I was a bit late to this meeting, but it's clear to me that you have an incredibly low interaction level, then a model per customer approach is not viable if you only have that one interaction. But what is that boundary? What level of volume does it become sensible to start using a model per customer?
Yeah, so it is something that you would need to test for your specific use case. But from what I've seen, even kind of as the low as 20 interactions can start giving you a pretty reasonable model. And then, as you get more, it obviously becomes more certain. But I would say that's if you don't have 20, then, it's probably not even worth checking. But beyond that, it is worth running tests and seeing, does this approach seem to have an impact with that amount of data? But yeah, the real answer is you need to test yourself for your use case.
Yeah, I mean, I suppose that's always the answer.
Yeah.
When you say 20, is that kind of time bounded? Like, is it one interaction per year over 20 years fine, or should it be like 20 a month?
Should probably be, again, it depends on the use case, but 20 over a few months is probably reasonable. But if it's something where you think that, maybe in a gaming environment with lots of new games popping in, like that's too long of a period. So you would have to think about, again, the specific use case. I would definitely say 20 over 20 years is not that useful, but 20 over a few months is probably okay.
So Eric, I've got a great one that I discussed with a client the other day. How many data points do you collect on a funeral policy? So that means that Ramsey's thing is that it's not a good implementation to personalize that, because the person is going to die once and your data point's gone. So I think we probably need to work on like more mathematically rigorous heuristics for rate of learning. And like Eric's saying, I think that the experiment will tell you, because if you do like in a banking world, something like a mortgage, and you collect 4 data points 4 times the person has bought something, even though you might have collected enough to personalize, the personalization is probably more of that person in that life stage that they're in related to other people. So that means that you need to use the collective to personalize. It's very difficult to then make it personal. But if you've got high frequency interactions, then you can, I mean, I know that in the telco world, we now know that a model in a high frequency engagement, people buying data and so on all the time, can converge in 4 days. So you need, a couple of data points and you'll know exactly how that person's going to behave in the future, because basically they exhibit ritual and, common products that they buy. So it depends on the scenario, I guess.
I'm wondering about, we were talking a lot about high rate of learning and converging in real time and all of that, but as human beings, you could behave in a certain way over a couple of weeks because you're going through some specific thing in your life, but then you return to a different ritual after that. And how does the model pick up when you are not necessarily demonstrating anomalous behavior, but you're returning to something that is also familiar to you? Like, how does it balance that?
So that is the whole kind of explore, exploit trade-off. So there's a number of different ways of doing it. The principle is to never assume that things are static. So you should almost always be testing out different approaches to see if someone's behavior is changing, whether it's changing to something new or going back to something old. You need to be kind of testing for that and using some of your interactions to do that. And when you see it happening, that's the benefit of the real-time learning, is that your model will then adjust to take that into account. But yeah, you can only do that if you are testing.
Okay, great.